Okay, so now we're on the next symbol, which it says there exists. So this is how we write it. So kind of backwards bracket with a line through it. This is how the typeset makes it. So there exists. So that means it's an existential quantifier. So there is an X in this set D such that Q is happening. So let me just kind of go back for a second. Look here. So when I had for every X in real, look at what I had every time. Every time I talked about for every, I took a pause with a comma. Now when I'm talking about there exists, there is one such that. So you always have to have the word such that and then kind of some statement after that. Okay, let's see if these are true or false. So there is an X in the integers such that X squared equal X. So there is one that I can find. Is there? Yes, there is. X equal 1, right? There is an X in the odd integers such that X is divisible by 2. No, that's false, right? Cannot find one of those. All right, so that's introducing the such that's. Let's move on to negations. So you're familiar with negations, right? So we're going to undo. If we have a true statement, we're going to make it false. If we have a false statement, we're going to make it true. Okay, so here's a negation of the universal statement for every X in D, comma, Q. So to take the negation of the for every is a there exists X in D. And since there's a there exists, you must put the such that, and then we negate the Q, so we say not Q. Okay, let's move to this next one. So I'm taking the negation of a there exists. So the negation of a there exists is a for every X in D. And then since I've got the universal qualifier, comma, and then negate the Q. Okay, so these are really important distinctions, just saying it in words here. All right, so find the negation of this statement. So taking the negation of a universal for every X in the real positives, there exists an X in the real positives, such that, right, anytime you say there exists, such that 1 over X, and you take the negation of this, X, and this is the way you say not. So not an element of positive reals. All right, take the negation of this. Negation of there exists an X in the integers is a universal for every X in the integers, comma, then take the negation of this, X squared does not equal X. Okay, so here I have these. This is an informal statement, right? Written in words. So what I want you to do is write it formally with the universal or existential. So figuring out from the words, is it a universal or existential? Okay, and then I want you to negate it. So 3 things, or 2 things I should say. Okay, so first off, the number 12 can be written as the sum of any 2 even integers. So I'm saying there are 2 even integers that exist. So there exists an m and n in the even integers such that m plus n is 12. Right? I can find 2 numbers, m and n, in the even integers such that m and n equal 12. Okay, take the negation of that. So the negation of this statement here, so if I take the negation of it, there exists, is a for every, still in the evens, there exists, the universal, comma, and then take the negation of this, m plus n does not equal 12. Okay, so here's the next one. This one here, this is an informal, right? This is informal, meaning it's in words, not in symbols. This is informal, in words, not in symbols. So first, write it formally. The sum of any 2, TWO, right? two irrational numbers is irrational. So that's any two. That sounds universal to me. For any m and n, and there's no symbol for irrational, so you just have to say the words. For any m and m in the irrational numbers, and since it's a universal for every, comma, m plus n is irrational. Okay? So then let's take the negation. So undoing the universal gives me a there exists, keeping them in the rational numbers there. Since it's a there exist, have to have the word such that, and then we're going to undo this, right? So not irrational is the way of saying rational.